from yale.edu, Yale Environment 360, titled How Thawing Permafrost is Beginning to Transform the Arctic.
Yep.
So this goes into a lot of the graphs we've been talking about, and in previous videos we've done, basically there's a lot of red and above average temperatures in the Eurasia section of the world. So,
And I certainly have covered my share of thawing permafrost in my
yeah,
some of my videos.
check out Science Talk with Jim Massa for more of that.
I mean, this that you got the lake there, and you see that slumping thing. You can tell that's like mud right there in the middle. That's the size of a football stadium.
Oh my God. Okay.
Just to put it in perspective, that's the size of a football stadium.
Ah.
So right at the 50-yard line is a big muddy ridge.
Well, you can see the Arctic is changing. The ecosystem is changing fast and rapidly. It's developing these craters and holes and lakes, but that's the permafrost thawing. This is the result of that, correct?
Yep. Also, you have these structures called pingos, which are basically, they look like mounds on the surface and they're covered with vegetation, but underneath it is a big thing of ice.
Wow.
It's called an iceland. Well, the ice is now melting, and then what happens? That thing just collapses in, and we're seeing a lot more pingos collapsing or disappearing, resulting in collapsing of the structures.
Oh my God. So the article,
So
oh, go ahead.
So you get also what's called liquefaction, especially if you have what's called permafrost, that the ground that's a thaw unstable. So you get liquefaction, which basically means the ground turns into a big oozy, muddy thing.
Yeah.
It's just, so if you have thaw unstable ground, when it thaws, the ground just liquefies and becomes this ooze. If you have thaw stable, so you might have a pile of frozen gravel, pebbles, and rocks. When it thaws, you just now have a pile of pebbles, gravels, and rocks. It's just
It's
it's like
rapid
that.
transformation.
It is. It
It's
is
turning to
major.
oozing mud, and it's because it's warming so fast.
It is. And when you take, for example, the Alaska pipeline, the Trans-Alaska pipeline that goes from Prudhoe Bay down to Valdez, 800 miles. Roughly 400 miles of it is buried, 400 miles is up on stands. Where it's buried, the ground is stable underneath it. It could be, when you go further south, there's not so much permafrost, but up north where there's more permafrost, if it's buried, it's thaw stable ground. Where you see it up on the pilings, that's thaw, it's going over thaw unstable.
I see.
Permafrost, because the pipeline, the oil is going to be warm in there. So if it's the heat's going to cause the liquefaction in the ground, and then the pipeline breaks. Then you have underground spills and that kind of stuff. So they drove these pillars into the ground, depending, 75 feet to sometimes 275 feet. They just drive these pillars into the ground. They put these sleds on top, and they rest the pipe on it. And they zigzag the pipeline to allow for expansion, contraction, and earthquake movements, so that when there's an earthquake, it can slide on these beds.
Wow.
on top of the up there on the sleds there, and so it's about 400 miles of that. And they also have, if you look on those things, there's these little fins that you see. They're filled with a coolant, and what the coolant does is, and they actually run in the wintertime. And what it does is it takes the cold, it takes the warmer temperature in the ground and dumps it into the atmosphere to keep the ground cold. And when does it do that? During the wintertime, because when you have the snow cover, it insulates, so the ground is actually warmer than the surrounding air. So it's warmer. It might be, say 31 degrees Fahrenheit, or maybe even 29 degrees Fahrenheit. The outside air might be minus 35. Well, it's outside air is colder, so it's going to take the warmer air, the warmer temperature in the ground, dump it into the air.
Wow.
So the ground cools down. And what the Alaska does, that's the pipeline company that oversees the Trans-Alaska Trans-Alaska pipeline. They fly helicopters. Helicopters have infrared sensors on them, and they just fly up and down there, and they just check to make sure each plume has an infrared signal.
Oh my God.
So they know it's working. If they see a plume that doesn't have one, oh, we have to do maintenance on that. They make a note of it and they send a crew out.
It's almost it's like high tech stuff.
Well, this is developed in the 60s and 70s.
Oh wow, and they're still using that technology.
Yeah.
No, it's good, I guess, if it's working.
But still, you know, things are changing up in the Arctic because of what's happening. And as we've been seeing now with the tracking the temperatures in Siberia, goodness gracious.
Yeah, it's way above average.
All that thawing, you know what's happening, what's being released from all that thawing.
And that's what we should get into because, well, the article says that 2.5 million square miles of permafrost, and they say 40% could disappear by the end of the century, which will release greenhouse gases, methane, carbon dioxide, nitrous oxide, and pathogens. So let's unpack this.
And by the way, you see it says, release of greenhouse gas, including methane, CO2, and nitrous oxide.
Mm-hmm.
Nitrous oxide is a recent discovery.
Oh.
As another greenhouse gas that's also being outgassed from the permafrost. I actually did a video segment on that of some guy doing his work up in Prudhoe.
Oh, wow.
They said, oh, look at this plume here. Oh, shit, it's nitrous. We got a new gas here. So nitrous oxide is a recent addition to our understanding of what's happening with the permafrost.
So what are the consequences of that gas?
Well, aside from the immediate, positive feedback loop of keep warming things up, you have communities that are, within the Arctic. Their infrastructure is going to be at risk.
Oh, wow,
the roads could crumble, the foundation. Because if you build a house, you're building with the assumption the ground is going to be solid. If the ground starts thawing and buckling and getting soft, your house is going to kind of crumble and crack and twist and fall down. So, along with the roads. So you have those consequences. You have to almost like start re-engineering things.
Oh, wow.
That's expensive.
That forces people off the land they were on.
And I did a video segment talking about that very issue.
Check out Jim Massa, Science Talk with Jim Massa for that. Another joke.
It's just, there are major ramifications. And don't forget, the boreal forest is the largest terrestrial ecosystem on the planet.
And it's becoming muddy
and you got all this permafrost. And yeah, it's becoming muddy.
Which means it's becoming warmer, which is just devastating the ecosystem, the Arctic ecosystem. Oh, the article also said real quick that when the permafrost thaws, it's going to be 4 times what humans have emitted since the Industrial Revolution. 4 times everything we've already done, 4 times that. At least.
If you were to ask climate scientists what is the issue that keeps them up at night, they will tell you it's the methane question. How much is in the ground? How fast will it be released? I've been saying this for some time. I've worked with people who study this. Igor Semiletov and his wife Natalia have been basically the ones leading the charge on studying permafrost around the planet. But they've done a lot of work in Siberia and just been doing stellar, amazing work. Really cool people too. Awesome. But yeah, it's the methane question, and
yeah.
The joke is, does the Earth burp or fart if a lot of methane is released at once?
It's just catastrophic.
Which end do you want to look at?
Yeah, it's catastrophic, Jim. 4 times. I mean, the feedback loop.
It is.
We're getting to be like 10 degrees Celsius as our global average temperature when that stuff, maybe even sooner. But it's projected to keep increasing.
Here's the interesting thing. I think the last time we spoke, we talked about how the carbon emissions, at least from burning of fossil fuels, has dropped like some 8.6%. But yet, I saw a thing where we crossed like 420 parts per million for CO2 levels.
Yeah, I'm gonna sneak that into this right now. It was from Zach Labe, your guy
Okay,
Zach.
let me get let me get good old Zach here.
He has
Uh,
some graphics.
let's see, because where I was going with that, let's see what, there it is. Where I was going with that is you still have power plants that are still burning coal or diesel, whatever. So they're still emitting, fossil fuel, emissions, greenhouse gas emission. But here's the other thing: you have all this warming going on. You have the methane being released from the thawing permafrost. And this is another reason why I sent you the sea surface temperature graph, is
Mhm.
the ocean's getting warmer and warmer. What have I said before? That gas solubility decreases with increased water temperature. We're starting to see the outgassing of CO2 from the oceans.
So the engines of essentially they're running by themselves. They don't need us anymore. They're producing their own warming effects.
We are
Oceans.
basically, I've been warning about this for some time, that as the oceans warm, they can't absorb the CO2, and at some point will start releasing the CO2 that they have absorbed in the water back into the atmosphere.
That's unbelievable. Wait, hold on. We're frozen again. Here we go. We're frozen. We're back. Okay. So
I don't know
that's
if you heard any.
unbelievable.
Did you
Just
hear
with
any of?
the
We
outgash.
froze up again.
Yes, I heard the last part. It was
Okay.
just how amazing. Like basically, the oceans are gonna be outgassing. They're gonna be creating their own
Yeah.
CO2, which is
It,
unbelievable.
you
Well, so
know,
sad.
it's around 3, say 10 or so in 1960, and then it just steadily goes. I mean, can it be a clearer graph of what's going on than this? How the
No,
CO2
this is
levels have continued to increase. And by the way, the little, you know, up and the little red graph that goes up and down, kind of like almost in a sinusoidal manner.
yes.
That that's just showing the seasonal fluctuations in the CO2.
But it's over long periods of time. It's getting higher and higher, and we just
Over
broke
the right,
another.
that's what the black line represents. The black line represents the fitted regression curve through the data point. But within a year, you're going to see variations within a year of where it peaks and reaches a low point. That's a seasonal variation. But even with the seasonal variations themselves are climbing.
Yeah, so it's like the low getting higher. Okay.
Yeah, and then and when you just fit the curve through through the points there, you get the overall trend, which has a positive slope. But
Would you
look at
say
that. I
this
mean, we're
is,
basically,
yeah,
that last point there. We're pushing. What the measure is, 416.21. Yeehaw.
just more records being broken, and all this energy is being stored in the atmosphere. Therefore, it's warming the planet further and further and further, and it's just, we talked about this before. Humans, we've stopped, but there's still industry going. But at the same time, even this little blip in pandemic history, 3 months, probably less because we're opening back up. Um, it's not. It might affect the global average temperature long term, but not really, because there's so much energy and CO2 in the atmosphere already, and it's just we're on. I feel like no matter what we do now, it's just like we're going there. We're going towards that future.
Well, it's what I've been saying for some time. It's just that there's enough thermal inertia in the system to keep driving this,
The thermal
and
inertia. Yeah.
even with, let's say, you know emissions of fossil fuels to go to zero this very instant, you've got the temperature that's going to continue. The warm temperature is going to continue to thaw the permafrost. You're going to have the continued outgassing from the oceans of the CO2. It's going to, it may slow it down to say 3 degrees C instead of say 5 degrees C by the end of the century. I'm just throwing numbers out there to make the point. But the point is, it's still going to keep warming, and with the consequences of said warming.